Hi, I'm Ashley.
I'm Dan. Hey, I'm Jan.
I'm Yan.
This is our sundial, and we have the group Sunwatch.
And we're gonna walk through our production process of our sundial.
And tell you how we made it and how it works.
Yeah, the function and objectives of the sundial. Our sundial's three main functions are to accurately indicate solar time, indicate magnetic noise, and determine whether it is on a flat surface or not. Our sundial is an equatorial sundial with a normal and hour lines, so it could tell solar time. There's a compass in a diplate, so it could tell the magnetic north direction. And the compass we use is a bubble compass, so it could tell whether the sundial is placed flat or not. Our sundial's three main objectives are universal, portable, and cheap. Because our sundial has a foldable hinge, it could be adjusted to any destination's latitude, and it could be folded and fit in a backpack. Our sundial is mainly made of 3D printed plastic and pieces of wood, so the production price is cheap and is less than $15. You can see our cost is just $7.90. It's very cheap. The actual size of the sundial is 14 by 10 by 5 inches, which is meet the constraints.
So hi, so today I'm gonna demonstrate how you should use the sundial. So since we're in Boston, our latitude is about 42 degrees. So this is about, we've already measured it to 42 degrees here. Yeah. And also, we also have a compass here. So we need to determine where the geographic north is. So to determine where the geographic north is, we have to look for the north direction. And because this compass only shows the magnetic north direction, and we're in Boston right now, it's about 15 degrees off. So we have to point to the north direction and then shift a little bit to 15 degrees. And then we have to find a flat surface to put it in the sundial, to put somewhere. Oh, sorry. So this is about 15 degrees north, and then we're all set. Hello, so today I'm going to teach you guys how to convert the sundial's time to clock time. So you know we have the hour lines here, and it shows what time it is. And then at the back, we have the equation of time graph that shows the difference between sundial time and clock time. So during the daytime, the sun will shine and the gnomon will cast a shadow on the hour lines here. And then here's the graph, and as I said before, it shows the difference between the sundial time and the clock time. So how do you use it? So I'll give you an example. So for example, when it's like March 15, mid-March, you go to January, February, March, and then you go to the middle here, and then you go down, and then you see a black line. When you see a black line here, you go horizontal to see a time difference, and it says +10. This means the sundial is a bit slow, so you have to add 10 minutes to the sundial's displayed time. So for another example, today is December 4th, and it's in the beginning of December. So you just go November, December, and then you go a little bit front, and then you go down until you see a black line, and then you go horizontal. and then you see it's about -11. So that means the sundial's time is about 11 minutes fast. So you simply have to subtract 11 minutes to the sundial's time. Yeah, so basically that's how you convert the solar time to clock time, and you're all set.
Alright, well this is our sundial, and the parts that it's made of is the base here was designed by Jan Henneke, and it was designed on SolidWorks, and it was printed in the first year learning center in Snell Engineering. And our center plate here, the part that moves back and forth, was made out of a single sheet of scrap plywood that we cut 3 times and glued together to get the desired thickness that we wanted. And the part that holds it in the side is actually just a small piece of plywood that can slide in and out however we want to. So we can slide it in and out, stick in here, which gets it to stay up, which is one of the most important parts. And then on the side over here, we have the hole for our compass, which was bought at REI for $10. We took it out of a carabiner for climbing. And there's also 4 rubber bands that can be adjusted to either side where we need it to be to hold this at the right angle. And in the center, we drilled a 1/8 inch hole. For our original size was a little too big. It was 5 millimeters, and we realized that it would cover up too much of the hour lines, so we couldn't really see. So we made it a little bit smaller, so now it's 3 millimeters, and it works perfectly.
So this is our sundial. You set it together like this, and this is our 3D printed part, the part that you see in the black one here. We have a hole where the compass is going to be glued in, and then you can put the flipping plate right in here. There are 2 holes on each side where the gnomon will be able to stick in. Also, the gnomon is able to move, so you can put it into the right angle. And it's a 2-sided flipboard, which makes it able to adjust it for the winter time, which will be this side, and the summertime, which will be the other side, just that way. We also included 4 rubber bands that will be able to hold the gnomon in the right position, such like this, and this will make us therefore we will be able to adjust it to a specific angle. You use just a thing here and put it on there, measure the angle in the right direction, and you'll be fine with that. Also, we have our lines printed on here, and there you will see that they have a top equatorial line set and a bottom equatorial line set, which is the summer line set and the winter line set. And on the back side we have the equation of time, which will allow us to adjust to the different times you will measure at different times of the year.